Good morning, everyone. I hope every one of you is in good shape in this period of extraordinary situation. I am Vincent Legros, Marketing Officer at Mercator Ocean International, and I'm very pleased to welcome you to this second training workshop dedicated to the atmospheric data products. So first, I would like to share with you some numbers I could collect from the during the registration. So we could see that we had 220 registration for this event coming from 56 different countries. So there is a global interest in Earth observation. As well, we could collect information during the registration concerning your interest in Copernicus core service data and satellite product. So as you can see, almost 1/3 of the registrants express an interest for all the Copernicus core service data and satellite products, and almost all the registrants for at least 2 or more Copernicus core service data. Means that WEkEO is a tool needed in the Earth observation community. So now let me introduce you the agenda of today's live session with the lecturers. So we will begin with Fabrice Messal. He's going to give you an overview of the DIAS WEkEO platform. Then Laia Romero will do an introduction of the product offer of WEkEO. We will continue with Joana. She's gonna make an introduction of the cloud processing environment. Then Julia Wagemann will do the introduction of the JUPYTERLAB and the Jupyter Notebooks, especially dedicated to atmospheric data products. We will have, at the end of this live session, a question and answer part where Martha Bertrand will be the moderator of this part. Okay, just basic rules for you, the participants. So considering the number of attendees, you won't be able to speak and ask live your question, but we have at the bottom right of your screen, we have a chat platform where the Q&A mode is enabled. It means that whenever you express the need to ask your question, simply type your question in the chat, added with the question mark, the gray question mark, okay? Then all your questions will be stored in the Q&A chat, and Martha Bertrand, the moderator, will display the most relevant question of the participants during the Q&A part, and the experts will have the possibility to answer your questions. Okay, that is clear for you, I guess. So the question will be displayed like that, and the expert will have the possibility to answer. So about the workshop, quickly. So you may be aware that there is 3 rounds. We are in round 1. So this is the live webinar of today. Then you will have round 2, which is like 3 weeks practical session where you will have at your disposal dedicated Jupyter Notebook to atmospheric data product, tutorial video, and the possibility to exchange with experts about question or blocking points you can have during this practical session. Then we will have a debriefing session the 29th of October 2020, where the expert will come back to the question you had during the practical homework, and you will have the possibility to ask live your question during this session. So we won't be able to answer all the questions, but no worries, afterwards you will have all your questions answered in a shared document. Quickly concerning the WEkEO account, Julia will come back to this part during her presentation, but we built a dedicated Jupyter hub for this training, and we had to register automatically the participant of this training. That's why all of you received an email yesterday to get your agreement about this automatic registration. For the participants who did not fill up this agreement, you have on the chat, Fabrice displayed on the chat, the address where you can give us your agreements for this automatic registration. So no worries, this will be explained in a post-event email where you will have a crystal clear explanation about this question of accessing the WEkEO platform. I hope I was clear for you. I leave the floor to Marta, the moderator, and she's going to introduce you the first lecturer of this session. Enjoy your workshop. Thank you.
Good morning, everyone. Thank you, Vincent, for your introduction. And we are going to start next with the overview of the DIAS WEkEO platform. And it will be Fabrice Messal who will do this presentation. Hello, Fabrice.
Hello. Thank you. Hello, everyone. I'm very pleased to be here with you today. So I'm going to introduce you an overview of WEkEO. So what is WEkEO? WEkEO is a Copernicus data and information access service. It provides you access to a large amount of data and tools to process this data. This is a single access point to this amount of data. And this is a web portal at wekeo.eu. So let's see what can you get from WEkEO. Data, of course. You can access to all the Copernicus and Sentinel data. As you must know, Copernicus is a European Earth observation program. So WEkEO gives access to all marine, atmospheric, climate, and land data produced in the frame of the Copernicus program, and of course, all the Sentinel data sets. So you can have data such as satellite observations, in-situ observations, or model data. WEkEO gives access to computational resources. You can choose to have virtual machines for your needs, test your codes on JUPYTERLAB, etc. Free trials are available for some of these computational resources pay plan. We will see that later. You can have access to APIs to help you accessing the data, like the harmonized data access. You can meet the expert. We have an efficient user support at your disposal. And in the near future, you will be able to showcase your work and promote it on a marketplace. So which data are available on the WEkEO platform? So Sentinel-1 data, Sentinel-2, Sentinel-3, and Sentinel-5P data, but also data from the different Copernicus services, like the climate change service, the atmospheric monitoring service, the marine service, and the land service. Today, this workshop is focused on the atmospheric data from the Copernicus Atmospheric Monitoring Service, some data from Sentinel-3 and Sentinel-5P data. But Laia, just after me, will give you an overview of this product offer. So why using WEkEO? So it's very important. It's very useful to use a DIAS platform to access data, because you have access to a large amount of data with computational resources. But the three main assets from WEkEO are: first, data is not a copy. Thanks to its infrastructure, WEkEO gives you access to up-to-date data, metadata, and documentation from the original sources. So you can access to Copernicus data in a timely way. Secondly, the harmonized data access. So this is a REST-based single protocol to help you accessing the data. It's very easy. You have just to enter your request of data, and you have a command line to put in your own code to access the data. So it's very simple access to the data. And of course, thirdly, the user support, because as you must know, Copernicus WEkEO is built by the 3 institutions, which are EUMETSAT, SEMWF, and Mercator Ocean. These 3 institutions have a lot of experience in Earth observation program and data, so you will benefit of the experience through this user support. To access the data through WEkEO, you have 2 solutions, 2 plans. The essential plan, which is a free plan. You can discover the data sets, you can download the data, and you can have access to a JUPYTERLAB to test some Jupyter notebooks, and you can have access to the support. And you have an advanced plan, which is a pay plan, starting from €66 per month. The content of the advanced plan is the content of the essential plan plus computational resources like virtual machines, processing tools, and in the near future, free networking. And Joana in this session will explain to you this later. A focus on the different advanced plans. We have a t-shirt size offer with different prices, depending the virtual machines, the number of virtual machines you need, the storage you need, the RAM you need to process your data. We have a trial period for 4 of these t-shirt size plan. And we are working on a pay-as-you-go plan to pay just what you are using. So to summarize, what can you do with WEkEO? So first, you can interact with the user support all along your experience on the WEkEO platform. You can contact the service desk through this email address, support@wekeo.eu. So you can search the data, it's for free. You can download the data, it's also for free in compliance with the Copernicus data policy. You can register for free, and after the registration, you can access to the Jupyter Hub to start computing the data, and this is for free. Then, if you need extra resources to compute your data or to store your data, you can apply to a pay plan, to advanced plan. A few words on the JUPYTERLAB or JUPYTERLAB platform. This is a powerful tool to make training and to share practical exercise developed by experts. You will learn how to use the WEkEO harmonized data access to help you accessing the data. You can test some codes. You can have access to the expertise from the experts through the different Jupyter notebooks developed by our team. So you will have access to a link to GitHub, and the Jupyter Hub platform is available on your dashboard once you are registered. So virtual machines are available in the advanced plan when you apply to have computational resources. This is a snapshot of the dashboard because you can access to all your computational resources through a dashboard or by using SSH access. And Joana will give you more details on that later. And to finish, I would like to refer to some tutorials videos available on our WEkEO YouTube channel. Some of them, the 2 first videos, are are highly recommended to start on the WEkEO platform. So I invite you, I encourage you to have a look to these videos. And I think it's all for me. Thank you very much.
Okay, thank you, Fabrice, for this presentation. I think it will be very useful to get started with WEkEO for those that didn't try it before. And right now, Laia Romero, she will introduce the WEkEO product offer. Hello, Laia. Good morning.
Good morning, madam. Thank you, Fabrice, for the introduction. I'm going to share my screen to go over the WEkEO data offer for atmospheric data. Can you see my screen? Okay, so we will go through the product offer in relation to all those data sets that are available and that are currently useful to the WEkEO users in terms of atmospheric data studies. But these are not limited, and you will see later as we will explore the WEkEO catalog at the end of this brief introduction. This is the data discovery platform that I will show you later, where you can check visually all the data sets in WEkEO. Those that are not available visually or graphically are still available in the catalog and can be downloaded from the same interface. What you can see here is the OG level 1 from Sentinel-3 and the Sentinel-5P for nitrogen dioxide. As Fabrice was mentioning, and I've seen in some of the questions already in the chat, in WEkEO, we do not only have satellite data. We have satellite data from Sentinel-1, 2, 3, and Sentinel-5P, and we have Copernicus services data from climate, atmosphere, marine, and land. In the WEkEO data catalog, we have, wait a second. Okay, in the WEkEO data catalog, we have these different data services coming from the different providers, and we will be reviewing the Copernicus Atmosphere Monitoring Service data, the Sentinel-3 data, and the Sentinel-5P data. For the Copernicus Atmosphere Monitoring Service catalog, we have three main products at this point, which are only a subset of what is available globally in CAMS. Sorry about that. Okay, so the first one is the global reanalysis, in where we have the single levels, the multi-levels for all the variables, the aerosol, the radiation, the chemical, and the meteorological. Archive single levels. Those are the CAMS reanalysis variables with estimates every 3 hours and a time period from 2003 to 2019 with global coverage, as I said before. Then we also have the greenhouse gas fluxes, which is the flux impression model using the observation networks from the different providers at surface, atmospheric mixing ratios, and column mean. And we have those at 3-hourly time steps for CO2 and nitrous oxide, which are available with instantaneous time steps and also monthly, and the 6-hourly, daily, and monthly for the methane. And also the solar radiation, direct, diffuse, and direct normal. You will see these in the platform. For the Sentinel-3, as you know, we have the Sentinel-3 Marine, which is super extensive in WEkEO, but within this, there are two levels of data, which are the sea surface temperature and the atmospheric composition, which are also widely used for atmospheric studies. And I will also show you this data offer. And finally, for the Sentinel-5P, as you know, we've got the Tropomi instrument with level 1B and level 2 data available in WEkEO. it gives us with a daily coverage, daily and global coverage of the Earth with all these data variables, which range from the NO2, which is the most popular, to methane, ozone, sulfur dioxide, and so on and so forth. So without further ado, let me share the screen again. Okay. We are in the data viewer now. I am signed out at the moment. So this is what an unregistered user can see. This is under the data tab in the WEkEO website. When you click on the layers, you access the catalog. And in the catalog, we can, for instance, type atmosphere in the free text. We get 27 data sets from, ERA 5, which is from the Climate Service, Sentinel-1, every data set that has some sort of atmosphere-related information in it. As we go through the catalog, we can decide, for instance, to add one of these data sets to our favorites. And once you do this, you are asked to sign in. So for all the registered users, free of use, for everybody, you can add as many data sets as you want to your favorites. This means that you will have at the left-hand menu a filter that is favorites, that you can consult always. In your favorites, you can add to map, and you can decide what you want to add to map. Okay? Let's add the methane. Okay. I want to show you here that you have all the variables available, and for OBJECTIF, for instance, or for CAMS, which I want to add also a CAMS dataset. Okay, CAMS is not available visually so far, although it will be in the future. But when you click on the download, you can still see all the information about the dataset. You can click on what you want to download, and you can actually download the data here. Okay. Once you click on what you want to download, you can see it on your API request. And I'm sure Julia will show you more about this. And I think that's it for me. I don't want to run out of time. I encourage you to use the DDP. You can set up areas of interest that are then applicable to each dataset. And you can very easily download the data and access the catalog this way.
Okay, thank you very much, Laia, for your presentation. And right now will be Joana Miguens that will tell us about the cloud processing environment.
Hello, good morning, everyone. I will be now sharing my screen. Just a moment. Application, and here we go. Okay, so we will be now hearing about WEkEO Cloud Services. The question is, WEkEO Cloud Services, what is the advantage to use Earth observation specific cloud services? We will go together three main points. The first one is the cloud services, the dashboard that you will be able to access online, start a very first virtual machine, how you can manage and operate your entire computing resources on WEkEO. The second one is how you can access the data through the portal and through a command line. And the very last one, we briefly will check how are the Earth observation service specific to Earth observation on the WEkEO Cloud Services useful for you. So let's go and start with the live demo. On the WEkEO portal, you will sign in and go to dashboard. On the dashboard, you will be exposed on the left with a GUI on. I will need to sign in again. Sorry about that. Okay, there we are. And on the dashboard on the left, you will be able to select the service that you want to access on WEkEO. And one of them is the virtual machines. The virtual machines will drive you to the GUI of the cloud processing services. On the very top, you will see here operations, provisioning, infrastructure, logs, monitoring, administration. Through this, you are able to add a virtual machine, delete or increase a virtual machine. You will be able to access different types of storage. If you go here to storage, so object storage, block storage, file storage, you will be able also to manage security settings. So whether you want to have a server online or you want to have a back-end database, you will be able to have different security settings on your environment. Also regarding security, when you are accessing remotely your computing environment, you can also upload secure keys on your environment instead of passwords and credentials. To operate your environment, you are also able to use a couple of different operations on the virtual environment remotely, and to monitor it directly on the GUI. So let's first see here how to add a virtual machine. How to add a virtual machine, you can also see on our portal under Docs, Guides. There are a couple of different instructions how to manage your environment. For example, here, creating and access an instance. Here is where you see the steps how to start your first virtual machine. Using security groups, as we just spoke about, is how you can define your security group or different security groups for different virtual machines. Using GUI on a virtual machine with Linux, here you'll be able to see how you can quickly install a dashboard, a desktop access to your virtual machine. So you'll be seeing the virtual machine as you usually see your laptop at home. You can add, so you can extend your virtual machine or decrease it, different volumes, or upload your own image of a virtual machine and use different types of storage. So going back to our dashboard, you will see here two different operating systems. You can also have already ready different types of virtual machines for you. My first virtual machine. When you are searching your first virtual machine, you can select different types of parameters, as for example, the version of your operating system or the plan of your virtual machine. So depending on your resources, you can decide to have many virtual machines, small, or one big virtual machine with many CPUs or a big RAM. All these settings, you will see on the guides again how you select and what is which one will be dedicated for your own need. Availability zones, security groups, and floating IP. The floating IP is where you will be able to select a public IP. So if you want to expose, for example, a web server or any kind of service to your own users, you will be able to have a floating IP, also to access your environment remotely. Once you start your virtual machine, you will go through the steps, click, and you will see the dashboard, how long it will take. It usually takes around 1 to 3 minutes to start a new virtual machine, and you will see the progress on your dashboard. Just to say that all the operations that you can do through a dashboard, you can also do through an API remotely. So here you can see a couple of different virtual machines that we have previously instantiated in this environment. So if I go back now and we will see here, we go to the second point. The second point was related with data access on your environment. So as Laia was showing on the portal, we have a viewer where you can easily find data and visually visualize what is the parameter that you are actually accessing at the moment. For example, now we have here Z surface temperature. In the Z surface temperature, we selected a couple of different parameters. And if you click here, show API requests, you will see here the selected parameters in the form that in the programmatic way to use it on your environment. This selection, we will go now to another window. I will switch the screen to the command line. So you can now see the command line, how to access the virtual machines that we previously instantiated. We just remotely accessed it, and we are going now to access the data. To access data, I previously copied the same request as we saw in the GUI just now to the virtual machine. And by running it, I'm going now first to show you here what we previously saw, the same parameters for Z surface temperature. I now click and I will make the request to have the download of this data to my virtual machine. So let me go through it and have here exactly the same download as you can do on the viewer of the WEkEO portal. We are now exposed with information about the jobs that have been created on the backend. So you can list many requests at the same time or a single request at one time. I will now actually click to order the download of this data. And by requesting the final step of the download, you will be able to see that we have downloaded in 2 seconds one file of 600 megabytes. So you have a very quick access to petabytes of data within the WEkEO platform by accessing remotely. We will go to another screen to the very third last point. So what are the advantages to have Earth observation specific tools? your data. I now stop sharing my screen and briefly resume that we went through the WEkEO cloud services, the access to the Copernicus data, and also briefly saw what could be the advantages to have already available for you processing tools and software on the WEkEO. Thank you very much.
Thank you, Joana, for your presentation. I think it was very useful to get more details also about the WEkEO. And right now it's going to be Julia Wagemann, who will tell us about the Jupyter Notebook and also the specific exercises for the atmosphere data.
Yes, hello everyone.
Morning.
I just start my screen. Okay, it works. Okay, I guess so. Good. So also a warm welcome from my side. My name is Julia Wagemann, and on behalf of EUMETSAT and together with MEO, I've been developing a Jupyter-based training on atmospheric composition data. And the next 20 or 25 minutes, I will present you how you can access these Jupyter notebooks on WEkEO, on the JUPYTERLAB of WEkEO, and how you can also exploit atmospheric composition data that is available on WEkEO. And for this, I would start with what Vincent already started with, that basically how you can enter WEkEO and then also how you can enter the JUPYTERLAB. And for this, you can go to wekeo.eu. And for those who have already an account, you can just sign in and everything should work. For those who just joined the training today the first time, you've been pre-assigned an account with the first part of your email address. So everything before the @sign is your username. And there you also go to sign in. Okay, now I'm already signed. So if you go to sign in, then you come to this interface. And for those who have not an account yet, you use the first part of your email address, and then you go to forgot password. And then you can enter, then you are prompted to enter a password. And with these credentials, you can then enter your to WEkEO. And I do the same again with my credentials. And so once you're entered or once you're signed into WEkEO, this is the interface you will see. And here you have a button which tells you go to my dashboard. And this is where you want to go. And so this is also where we are going now. Okay, so you see here your user profile, but where we want to go is to the Jupyter Hub. And if we go to the Jupyter Hub, in your case, so you see this interface, so you get different server options presented. But in your case, so because you signed up for this training, you will even have 3 options presented. You will have the beginner mode, the expert mode, and also a training option. And for the training, I ask you to enter the training option. And then you can start a server. Don't worry, it will take a bit, but eventually it will start. And once the training server started, you will come to this interface. And this is the JUPYTERLAB of WEkEO. And the JUPYTERLAB is basically a software development environment where you can program with Python, but you can also access you can install libraries, for example, via the terminal. And so via the launcher, this is basically your access point to anything. So you can start new notebooks, you can also start new terminals or text file, etc. On the overview here, you see different folders. And for the training, so as Fabrice already said, that we have a GitHub account where we make available all the training for WEkEO. But for this today, for the training today, we, under the public data folder, all the content that is available on this GitHub account is also made available for you already. And so if you double click on the public folder, you see different subfolders. So for example, a subfolder with WEkEO HDA, with Ocean, with EO data, and with atmosphere. And so under EO data, there is all the data which we will need today for the training available. So you don't have to download the data now, but you can. But we prepared some examples that you can try out the harmonized data access with WEkEO in the next during the next 3 weeks until the debriefing session. But for today and for exploring the atmospheric composition data, you don't have to download the data. It is already downloaded for you. Then there is also the training with WEkEO already started some weeks ago, and we already had some training for ocean data. And so if you're interested in this, you can also exploit the notebooks under the ocean subfolder. And under the WEkEO HDA, this is a specific folder, if we go in here, that showcases you how the harmonized data access works, and also provides you the functions that are required in order to execute the harmonized data access. But today we go to the atmosphere folder. And so you see here an overview of several notebooks, but you start with the index notebook. And if we do this, so you can start a notebook just by double-clicking it, and then you see the notebook opening. And in the index notebook, we provided you an overview of the training and also some more information which are important in order to get started. So as we said already, the training today, or the training on atmospheric composition data, consists of 2 parts. So the first part is today, where we will give you an introduction to the JUPYTERLAB and the notebooks that are available, and also to provide you access to the WEkEO and JUPYTERLAB. And then for the next 3 weeks, you have a self-paced, you have a period of self-paced practice for yourself, so you can go through the training. We will have also a Google form where you can submit questions in case you have questions. And then in 3 weeks' time, on the 29th of October, there's a debriefing session, and we will address all these questions during this debriefing session. Some more information to accommodate or to make it easier for you to work on the JUPYTERLAB. So what I said, that all the content under the public folder is already made available for you. But in case you have other code or information or work examples on GitHub available you would like to bring to the JUPYTERLAB, we provided you here an example how you can do it. So you basically have to clone the repository you would like to have on JUPYTERLAB into the JUPYTERLAB, and you can do this with this command here. So this, and the same we did today with the content which is available under the WEkEO JUPYTERLAB GitHub repository. But you don't have to do this because this is already done for you. And then another step which you have to do if you want to take advantage of the visualization libraries we make use of during the training, because there is an incompatibility issue with Cartopy. you have to first uninstall Shapely with pip uninstall Shapely, and then the second one you have to install it again, but with the no binary flag. And so if you run this in a terminal, so you go back to the launcher, you open a terminal, and then you run these two lines, then you can make use of all the visualization functions that are part of the training. Any questions you have related to atmospheric composition data and the Jupyter notebooks, we ask you to submit via this Google form. So if you open the index notebook, you have the link here, and we will address these questions during the debriefing session. If you have any questions about WEkEO and general about the JUPYTERLAB, then you can either send an email to support@wekeo.eu, or you can also use the WEkEO support desk web form. Okay, so this was now the introduction into JUPYTERLAB, and but now we can really get hands-on with the atmospheric composition training. You see here an overview of the notebooks that are available specifically for atmospheric composition data training. And so the first one provides you an overview of what type of data is covered and also what type of atmospheric composition data is available. And then you see here already, we will show you 3 different data sets. So the first one is Sentinel 5P Tropomi data. The second one is Sentinel-3 OLG level 1B RGB composites. And the third one is data from the Copernicus Atmosphere Monitoring Service, the global reanalysis data. And for each data type, we have 2 different notebooks, or two different types of notebooks. So the first one is how to retrieve data. So this is a specific notebook for this specific data set, which guides you through an example how you can retrieve data with the harmonized data access. And the second one is an example on how the data is structured, how you can load the data, in what data format the data is made available, and also an example on how to visualize the data. And these examples are available for all the 3 data sets. But let's go first to the atmospheric data products on WEkEO to give an overview. And so you see here the type of data that are available on WEkEO. So this is an example of Sentinel 5P Tropomi. This is an example of Sentinel-3 OLG level 1B. And this is an example of CAMS global reanalysis. And all the 3 examples showcase an example of recent fire events that took place. And so this example is specifically for the fires in Australia that occurred at the end of 2019 in December. And this example shows how the different data sets captured these fire events. So we provide here you just a bit more information about the data products, also on differences and also the variables that are available on the data, and also in what format the data is available. And so I just invite you to have a look through it and familiarize yourself with the data, atmospheric composition data on WEkEO. For today, I will start now with Sentinel 5P data and to guide you through an example how you can retrieve the carbon monoxide of Sentinel 5P Tropomi data with the harmonized data access. So basically how you can download data from WEkEO directly into your JUPYTERLAB. And this is and for this you open the notebook Sentinel 5P level 2 retrieve, And this gives you an overview of the HDA API workflow. And this is a 6-step process. So we see here, first, you can search for the data set on the WEkEO interface, what Laia already introduced you to. Then we get an API, we get the WEkEO API key, and then we initialize the data request in order to download the data. And so this example is specifically for Sentinel 5P. The first part is always to load required libraries. And the second part is that basically the retrieve this HDA API example, we make use of several functions that work in the background. And in order to be able to make use of these functions, we also load these helper functions with this command. If you're interested in the functions itself, you can have a look to this notebook, HDA_API_functions, and you see all the functions that are available in order to make use of the HDA API. So first of all, so the first step would be always to go to the WEkEO interface to look for data you're interested in. So in our case, we are interested in Sentinel 5P. So you can open the catalog by going to the plus sign here. Then the second step is that you have the interface phase where you can look for data. So you can either use the predefined navigation pane, or you can also enter a free text search. And once we identified Sentinel 5P, we say we want to add the data to the map, and then a interface is opening up with different variables that are available from Sentinel 5P. And so in this case, we would like to use carbon monoxide. And so you can select it, and then the data is added to the map. So once the data is added to the map, we can say we would like to request data. So we go to this download button, and then an interface is opened with different information we can enter in order to tailor our data access. And so for this example, we would like to just retrieve the data for a specific bounding box. So for the Australian fire example, for example, then for one specific day, the processing level we're interested in. So in our case, it's level 2, and also the product type. And in our case, it's carbon monoxide. There is now an update even so that in the interface, we can also choose the timeliness parameter. So if it should be near real time or offline. And then you can go either directly to request the data, but because we want to use the data on the JUPYTERLAB, we can click the show API request, and then the API request that is needed in order to request the data from the notebook is available here. And so basically we copy paste this API. So we copy this API request, and we can save it as a JSON file. And so we already did this also for you. So if you look to also on the overview, if you open the s5p_data_descriptor.json, can also open it, you see that it's a JSON file, and it's basically all the information we entered into our interface. And so for this JSON, we just copy pasted the API request and saved it as a JSON file. So the first step is that we define the dataset ID, and so the dataset ID is also given to you in the API request, and so we can copy paste this, and we can just define it as the dataset ID. The next step is then to get the WEkEO API. And so here you will need your username and password. And for this, you can basically enter your username from the WEkEO and the password, and then you can generate an API key. There is more information on if you don't want to enter your username or password, you can also generate an API key in an external website, and you can just pass the API key here. Also, you can just paste the API key here. Once you did this, we can then start to initialize the HDA API request. And so for this, you define a download directory path. So in this case, for example, a path in your local JUPYTERLAB folder, and we define a folder data. And then we initiate the HDI dictionary. And with this information, with the dataset ID, API key, and download directory path, we can initiate the directory. Then we can request the access token and also to accept the terms and condition in order to be able to request the data. And once we accepted the terms and condition and the access token, we can basically load our Sentinel-5P data descriptor file, which we see here. And then with the following 3 steps, first we have to create a job ID. And with this job ID, we can request a list of results of the data. And once we have this list of results, we can assign order IDs to each entry of the list. And the order IDs are then downloaded and can be requested. And so I just invite you in the next 3 weeks to play around with it, and also to understand the different steps, and also maybe to make changes to this data descriptor file. So choose a different bounding box, choose a different data variable to familiarize yourself with the HDA API request. The next step, I go then to just an example of Sentinel-5P data. So once you have the data downloaded with the HDA API request, how Sentinel-5P data is structured, and how you can actually browse it, get the information you need or you're interested in, and also how you can visualize it. And this is, you can see under the Notebook 11, Sentinel-5P Level 2 Load and Browse. Okay, so each notebook has the same setup. So it tells you here what this notebook is about, and it also gives you a module outline. So the outline for this notebook, it has 3 steps. So first we load and browse the data, then we create a geographical subset, and the 3rd step is to visualize the Sentinel-5P carbon monoxide data. And for each notebook, we have to load common libraries, for example, XArray, NumPy, or Matplotlib. And we also make use of specific helper functions in order to visualize or generate visualize the data, or to generate a geographical subset. You can see these helper functions in the functions notebook here. So you can open. Yeah, so you can open this notebook, and all the helper functions that are available for this training on atmospheric composition data you see here. So we have 3 different functions that are related to data loading and reshaping, and we have 2 functions that help us to visualize the data. Okay, so we also load this data. Okay, good. So Sentinel-5P files are organized in 2 groups, in product and metadata. And the product group stores the main data fields of the product. So, for example, latitude and longitude information, but also the data itself. And the metadata group provides additional metadata items. So for our data, for the data we're interested in, we have to load the data, the product group, because this is where the data itself and also the latitude and longitude information is stored in. The Sentinel 5P data is disseminated in NetCDF. And so NetCDF data, there is a Python library called xarray, which is very effective and efficient in handling NetCDF data. And also the entire course relies heavily on the xarray Python library. And so for this, in order to open a data, we can, or even multiple data files in the NetCDF format, we can use xarray's function open mf dataset. And for this, we specify the function. So xarray open mf dataset. We specify the path to the data, so which is in the EO data folder, Sentinel 5P, carbon monoxide 2019, and then the day. As concatem, because we want to concatenate the different data based on the number of measurements in along each track. And so this is the scanline dimension. So we want to concatenate it along the scanline dimension. We want to combine it as nested, and we want to open the group product. And with this, we open the Sentinel 5P data file. Oh, I have to run the library before, and then it should work. And then you see the data. You see the data set. So a xarray data set has been loaded. We have now 5 different dimensions: corner, ground pixel, layer, scanline, and time. Different coordinates, and also an overview of data variables. So data variables is carbon monoxide, total column precision, total column, QA value, delta time, and time underscore UTC. And so you see here the dimensions and also the data variables. And in our case, now we are interested in the variable carbon monoxide total column. And we can specify, or we can select specifically this variable by bringing it by selecting this variable in square brackets. And if we run the cells, so we see that from our data set, which hold different data variables, we now just chose one data array, which holds the data for carbon monoxide total column. And here this data array has 3 dimensions, so time, scanline, and ground pixel. And we see also additional attributes to our data. So for example, what unit the carbon monoxide total column has, what standard name, what long name, etc. And also important, a multiplication factor if we want to convert the data from mole per square meter to molecules per square centimeter. So, and this information, they might be useful, specifically these attributes for plotting later. But now we can not only choose the variable, but we can also select latitude and longitude information. And so we can do this. And you see here as well. So we have now a data array for each of the longitude and latitude information. So we see already that we have here 3 dimensions, so 1 dimension on time, but in the end we only want to visualize 1 time step. And so the next step would be now to select 1 specific time step, so the single time step that is available, and we can do this by selecting the first time step, but selecting all the other dimensions. And if we do this, we see that now we selected one specific time. So as the coordinate, we have the 29th of December 2019, and our data array has a scan line and ground pixel information. Because we want to convert the data from mole per square meters to molecules per square centimeters, we now apply the multiplication factor, and for this we load also this multiplication factor and call it conversion factor. We do this, and the same we also do for long name, because we can use the long name for visualization. So we also let run this one. And now we can create a geographical subset. So the geographical subset we're interested in is for Australia, because this is where the fires happened. So we specify longitude and latitude in bounding box with longitude and latitude information. And then we can make use of the function generate geographical subset. If you're not sure what the function, what keywords the function takes, you can simply use the question mark and then the function name, geographical subset. Generate. Oh, okay. There's geographical subset, and then the doc string opens. So you see that this function takes an X array and the bounding box information. And so we generate a geographical subset, and now we see that from. So we have the geographical subset, and then the next step is to convert the data and to apply the conversion factor, which we already applied. And so we apply this factor to our subset data. And once we have this subset data, which is converted to molecules per square centimeter, we can visualize it, and we can make use of the visualize p-color mesh function. And for this, we need our data array, which is converted. But for easier visualization purposes, we multiply it by 1 times to the power of -18 in order to just make the visualization easier. And then we use the longitude and latitude information. We apply a color scale, a unit, the long name, which we loaded, bounding box information, and if we want to have a global data or just a subset. And then we visualize it, and then you see the fire occurrences in Australia. So these were now 2 examples for how you can retrieve data and how you can also load and browse and visualize Sentinel-5P data. I just open now the example for load and browse Sentinel-3 data, and also for CAMS. Because I'm almost finished with the time, I just invite you to also go through these examples. So they have the same setup. So basically, you see here an outline of the data of the notebook, what different steps it contains in order to make use of the data and in order to visualize the data. And you can just follow the notebook, and it is also described what each step is doing. So in the end, what you produce out of Sentinel-3 is a Sentinel-3 true and false color red, green, blue composite for the 29th of December, which showcases also the fire occurrences on the Australian coast. And the same if we open the notebook for Copernicus Atmosphere Monitoring Service. You also see an overview, And this is the same. So the notebook showcases an example how to load and visualize global reanalysis data from the Copernicus Atmosphere Monitoring Service. And you see here, this is an example of organic matter aerosol optical depth that also showcases the fire events in Australia on a global scale, but then also how to create a geographical subset. And with this, I would now stop my presentation. And if there are any questions, as I already said, we have now a questions and answer session, but you can also submit your questions on this Google form, and we will address these questions during the debriefing session end of October. Thank you.
Oh, sorry. I was muted. Thank you, Julia, for this presentation and this demo. I think it will be very useful for the people that really want to know in detail how this data can be processed and how they can work with this data. And right now we are going to start with the Q&A session. And we have some questions that have been answered asked already on the chat. So if you want, we can start with that. We just received this question about the Python version used. If you know about it, Julia?
Yes, it's 3.6.
Okay. Thank you very much. Then we have one question related to atmospheric data about the access. So if apart from WEkEO, is there a website that can directly download atmospheric data from Sentinel satellites? Then I would say, like, what is the difference between WEkEO and that other website, if there is?
Yes, so basically so you can download the data also on on other access points. So for Sentinel-5P, there's the Sentinel-5 hub. For CAMS, there is the Copernicus Atmosphere Monitoring Atmosphere Data Store. Sorry, but for the benefit with WEkEO is basically that you can get different type of data. So in one data access system, and then you also have already the processing capabilities right on your hand, rather than you have to download it on your local machine and then process it there. I think this is the biggest benefit, that you have access points to different type of data, to Sentinel-5P, Sentinel-3, to CAMS data, which otherwise you would need to access 3 different systems in order to get the data.
Okay, thank you. We have some questions and comments regarding registration, and I think they are particularly very specific to this webinar. So I'm just gonna show one of them, and it's if this account, this WEkEO registration, is active permanently.
I think this is Fabrice can respond to it best.
Okay, yeah. What I know is that for any account, when you register at WEkEO, you have your account active permanently, and we can clarify with Fabrice if this account for the webinar will also be used after, if it can be used afterwards. So we will probably send this information in an email address. Or hi Fabrice.
So yes, the account is active permanently. Yes.
Okay, thank you very much.
Even the account we created exclusively for the training for people who didn't have an account before the training. Okay, it's just a normal account like the others.
Okay. So we continue with questions more related to the virtual environment and the Jupyter notebooks. So the next one is if there is a virtual environment available to all the libraries needed.
Yeah, so this was for the training. We will make this available. Also, because what I showed you with the example that we have to uninstall and reinstall Shapely. So this will be made available in the next week. That we also get that you get an overview of different libraries that are needed. But for the training itself, if you access the JUPYTERLAB, you already have the environment that you need in order to go through the training.
Okay. Thank you, Julia. We go to the next question. I think at the beginning it was not very clear what processing tools are. Maybe it is right now, but if you want to quickly summarize what are these processing tools?
So processing tools, you mean in order to, on the Jupyter notebooks? Or, so basically...
In WEkEO in general. So yes, please go ahead if you want.
Yeah. Okay, so probably also Joana can also give something, but so on the JUPYTERLAB, basically you can you have access to Python, and with Python you can process data, and so this is on the JUPYTERLAB, basically the processing tools, and then you can make use of libraries, etc. But I think probably this could be also related to Joana, I think.
Yes, exactly.
Okay.
So this is like the here is Joana. So now we have a clarification from Vivian that saying that she refers to the processing tools you pay for.
Exactly. This is a very good question. So on WEkEO, you can have, for example, on the virtual machines, already prepared, pre-configured virtual machines with different tools. So with different softwares that you can immediately make analysis or transformation of the data. This is useful for two reasons. One, that it's already ready in a few minutes, like the usage of softwares like Snap or View, GDAL libraries, or also because you will be able to know which softwares we are using, and if something is still missing and you would like to have, you can also somehow contribute to the increase of the offer of WEkEO. Besides this, there are also coming up web processing services where you can do a process as a request. So you make requests directly as an HTTP request, and then you get the feedback result of a heavy process that is done on the background. There are also web map services coming up, and also some other processings that can be prepared on the background, like transformation on heavy data like Sentinel 1 and 2, and that can be prepared for you and exposed, for example, in a bucket, in an S3 bucket. If you have any specific processing that you are interested on, we can also investigate that for you.
Okay, thank you, Joana. We have another question related to the types of data. So I'm gonna show it. If it's if it is available at WEkEO, the data of waves like significant wave height, wave periods, and in different time periods or different time scales. Joana, do you think you can answer this question, maybe?
Yes, this is quite specific. Would be easier to answer if you have the specific data set that you refer to. In terms of timescale, for sure, you can access in all the different timescales available. So whatever is available in other data sources, this is exactly the same information that you get on WEkEO. So the same granularity in timescale and also in period. For example, for the future ones, this will be more related with climate change data and also with atmospheric data. So when the Copernicus services have this information available, a forecast, this is exactly the same as you can access through WEkEO, the same information. About the wave period and the date of wave, these I would need to look exactly to the specific data set to be able to answer you. If you could provide a little bit more of details, we will definitely investigate it for you.
Okay. There is a similar question about availability of data. I will show you, maybe you can provide some more details about it. So there is a similar question of availability of data sets from the UK Met Office, if it is available at WEkEO, so like wave data forecast.
On WEkEO, we currently have Copernicus data, so the Copernicus satellite data and the Copernicus information monitoring services. This is C3S, CAMS, CMAMS data that you can access. So this specific one, if it's currently only accessible through the WEkEO Met Office, this would be included in the contribution missions. So WEkEO is growing into adding now in the future also contributing missions, and this is the type of data that would be interesting to add, but is not yet accessible, unless is also accessible through the C3S services of ECMWF.
Okay, thank you, Joana. I think that this answers this question, and also another one that was asking if WEkEO contains mainly satellite data or others. So I think that with your answer, this is also clear already. I don't know if you would like to add something else, but I think.
Yeah, so it's not only satellite data. It's really very important, a part of having Copernicus information services, monitoring services like CMAMS, the marine monitoring service, C3S, the climate change monitoring services of Copernicus, and also CAMS, so the Copernicus atmospheric monitoring services. This is very, very rich information in different parameters, on the marine, on the land, and CLMS data, also Copernicus land monitoring service with enormous diversity of data, forest, wetness, really very varying. So it's definitely not only satellite data.
Mm-hmm. Okay, thank you, Joana. We have some more questions. So the next one is related to the post-COVID governances, or like the post-COVID Earth observation-based governances that address global, societal, and commercial challenges. So do you know if we have some information available about it right now?
So what we have on WEkEO, it's the possibility to ask free computing resources. With free computing resources are accessible for everyone that has a project to do with Copernicus data, that will have a short period of free resources, but for specific projects on COVID-19, related with Earth observation project, there will be a lifetime of 1 year for these related projects that can ramp up on WEkEO.
Mm-hmm.
And this is basically what we have related with COVID-19. And it will be very valuable for you and for us also to host these services on WEkEO. So if you have any project related, we are really very happy to hear about it and work with you on it.
Okay, thank you, Joana. we have more questions already. I think we still have some time to answer them. So the next one is about availability of functions such as anomaly detection along temporal axis. I am not sure if Julia or yourself, Joana, you can answer that, or.
So I can. So basically, the training itself does not contain those functions. So the training itself just contains functions on how to subset data and also how to visualize data. So the training Jupyter Notebooks not.
Okay, thank you very much for your answer, Julia. Let me check. I think we are almost done. We have one last question. So yes, we have another one, like asking about the detail of data in general available from WEkEO. So is it still need to make field observation to validate those data? I'm not sure if Joana or yourself, Julia, if you're still there, you can answer this question.
Hi. Yes, this is a very interesting question because on the metadata of all the data sets, so if you go to the portal on the viewer, each of these data sets that you access have related metadata. And there are also parameters related with quality of the data and validation of the data. But mainly one of the main aspects that you can rely on data coming from the Copernicus services, it is definitely the validity of these data. So when there are campaigns for reprocessing data that include new available data computed with more in situ data, this will be also made available for you immediately. So all the data that is newly available and validated, it's immediately accessible in real time from WEkEO.
Mm-hmm. Okay, Joana, thank you very much for this last answer. I think we are already done with the questions. I think we finish this webinar now. And yeah, I think Fabrice is coming now.
Thank you very much,
Vincent.
Marta.
Okay, thank you, Vincent.
Thank you very much, Marta. It was a very pleasant webinar session. I hope you all enjoy it. And now it's time for you to practice. So you will have 3 weeks to practice. So after this webinar, so this afternoon, you will receive automatic thank you email from our webinar platform. And after that, I will forward you an email with all the links needed for your practical session. So tutorial videos, recording of this webinar, access to the Jupyter Hub, etc. So if you have any blocking points, don't hesitate to write us an email at training@wekeo.eu, and we will be very pleased to answer you straight away. So I wish you a very pleasant homework, and I hope to see you all in the debriefing session 29th of October. Thank you very much. Bye-bye.